seen it before. I know most of you are very good at remembering how to plot points. Just for a simple review before we take it a little bit further, plot 5, 2. That means that I go over 5 and up 2 and plot that point. Plot 4, 1. Over 4 and up 1. Plot 6, 3. Over 6 and up 3. And this question mark is here because it wants to know if you could find another point that would end up in this line. And indeed, there's an infinite amount of points that could fit on that line. The most obvious is 7, 4. You are going to find that as you progress through math, these lines match patterns. Let's identify the points that are here, remembering how to write these. This is the x, and this is the y. X before y. You crawl before you stand. So if I'm going to identify point A, I'm going to go across the x and then up the y. So my x is 7 and my y is 9. So A is located at point 7, 9. B is located at 10 and up 0. And C is over 2, up 8. So, you're familiar with the coordinate grid, but because we've introduced you to the other side of numbers, you must be inquisitive about why an arrow is here and why an arrow is here and not here. It's because this continues to go on and on, and this is called the origin, which is point 0, 0. Let's take a look at what it looks like. Here is the coordinate grid with the purple outline of the one we just identified. But you can see that this horizontal number line that we've already identified with integers on it goes in this direction, and then this direction for the vertical, which leaves us with 4 parts to this Cartesian grid. A Cartesian grid, sometimes called a coordinate plane. The points that we plotted on our last screen would show up in this quadrant. There are 4 parts. They are called quadrants. So this is quadrant 1. This is quadrant 2, 3, and 4. Now, it makes sense that this is quadrant 1 because these are the ones that are positive, and this is the one that you were first introduced to. But sometimes students get confused because they want to start here with 1 because that's what's natural when you're reading from left to right. So we remember that quadrant 1 is here, and connecting the quadrants makes a C, which is what starts the Cartesian grid. So you would plot points on this just as you would the other. You would go on the x-axis first and then the y-axis. X, Y. So here is our Cartesian grid, and it wants us to identify the points that are here and what quadrant those points are in. Then we are asked to connect A, B, C, and D, figure out what shape it is, calculate the area, and then identify that D is the vertex of what angle. So there's a lot of things that we can do with this Cartesian grid. Let's start by first identifying the location of the given points. Where is A? If I start at my origin, 0, 0, and I go the x first, I want to go to the A, so I'm going to go over to 1, 2, 3, 4, 5, and then go down to 1, 2, 3, 4, 5. Point A is found at 5, 5. I'm sorry, 5, negative 5. It's very easy to get confused, and I just did. 5 over, and then when we go down below 0, we're in the negatives. 5, negative 5. Let's try B. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So B is at 5, 5, which is my x point and my y point. Point C is over here in the middle of our question, but we're going to identify it the same way by going across and then up, by crawling before we stand. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So C is at negative 9, 5. This point is negative 9, 5. Point E, or point D, we'll do that one next. So let's go over negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, 1, 2, 3, 4, 5. So D is at negative 9, negative 5. And E is at negative 2, and we went up or down 0. Negative 2, 0. So now let's identify the quadrant that each point is in. Point A is here. And if we remember, our quadrants are numbered 1, 2, 3, 4. Quadrant A, or point A, excuse me, is in quadrant 4. That's a Roman numeral for 4. It's okay if you call it quadrant 4 like that as well. Point B is in quadrant 1. Point C is in quadrant 2. Point D is in quadrant 3. And point E is on the x-axis. We don't have a quadrant that E has moved into because it is on the x-axis. So, now it's given us 4 points. We have our quadrants, and we're going to name the quadrant after we've plotted the points. The first point is negative 7, negative 5. Over, then up. Negative 7 is in this direction, 1, 2, 3, 4, 5, 6, 7, and up 5. Negative 5, down 5. 1, 2, 3, 4, 5. This point is negative 7, negative 5. And this is quadrant 3. And every point in quadrant 3 is a negative, negative. 2 sets of negative numbers will always be plotted in quadrant 3. Negative 2, 3. Over to negative 2, up to 3. This is in quadrant 2. Negative 2, 3. And every point in quadrant 2 will be negative, positive. Negative 4, 0. 1, 2, 3, 4. And up or down, 0. This is negative 4, 0. And again, it has no quadrant because it is on the x-axis. 4, 2. Positive 4, positive 2. 4, 2 is in quadrant 1, where every point is 2 positive numbers. So I may ask you to find a point in quadrant 4 and tell me what is true about every number. If we just plot this, then we could say this is 1, 2, 3, 4, negative 2, which tells us that every point in quadrant 4 is a positive-negative combination. So you have a positive-positive and a negative-negative, and then two different combinations, one with a positive first and one with a negative first. Lots of patterns to be found on a Cartesian grid.